Hi, my name's Claire Gallagher. I'm the author of Maths the Wacky Way, which is a GCSE maths textbook to help students with their GCSE maths. Now I'm here today to run through indices to make them a bit more wacky. An index is where we have some unknowns. So you might see an X, you might see a Y. It's all about bringing them together and simplifying them. Let's take, for example, y to the power of 4 times y to the power of 5. Now, because they're both y's, what we're able to do is actually simplify it together. Now, if they were different, if we had a y and an x, we wouldn't be able to simplify them. Because they're two y's, we can use a rule which will just bring them together nicely. What we're going to do is we're going to look at the multiplication sign, and this needs to be up in the air because the numbers 4 and 5 are up in the air. Now, the multiplication sign is down here. We need to take it up, and because it leaves the ground, it's windy, and it twists and becomes a positive. So the times is going to leave the ground, go up to join the numbers, and will become an addition sign. That will therefore mean that we add the 4 and the 5 together, which gives us y to the power of 9. It's as simple as that. Let's take another one. So if we have a look at y to the power of 7 times y, what you might think with this one is, well, let's take the multiplication sign up into the air. It will twist and become a plus. Let's add them together. Well, there's a 7, but there's nothing else there. What we have to be careful of is y on its own is actually y to the power of 1. It's not y to the power of 0 because then it wouldn't be there. That would just be 1. So y on its own is y to the power of 1. 7 plus 1 gives you 8. So we're doing exactly what we did before. The multiplication sign is going up in the air, it's becoming a positive, and that therefore gives us y to the power of 8. Now hopefully we're okay with that. So let's bring in some more numbers. If we have a look at the next example, we've got 3t to the power of 5 times 4t to the power of 6. Now in this example, we've got two levels. We've got a level where the multiplication sign is, but we've also got another level up where the powers are. Now the multiplication sign, where there's numbers on that level, we will use that sign, we will multiply. However, like we've been doing before, where we need it to go up in the air to join the other numbers, that again is windy, will go up, twist, and become an addition. So we have the 3 times the 4, which will give us the 12. Then we have the 5 plus the 6, which gives us the 11. Bring it all together, we have 12t to the power of 11. Let's just try one more of those. So the next example we have is 6m to the power of 5 times 9m. Now we've got the same issue here in that we've got two levels, but also m is on its own, and as we've seen already, an m on its own is m to the power of 1. So 6 times 9 is 54. Now if we don't know how to work out our 9 times tables, remember one way you can do it is to use your hands. If we were looking at 1 times 9, we'd put the first finger down, that just leaves us with 9. Now if we were looking at 2 times 9, we put the second finger down, that would then leave us with 1, then a gap, and 8. That gives us 18. 3 times 9, again, splits these up 2, but then with my 5 fingers on this hand, we get 27, etc., etc. So that's a good way for us to work out our 9 times tables. Now obviously we don't have 12 fingers, we can only do it up to 10 times 9. You just need to remember 11 times 9, which is of course 99, and 12 times 9, which is 108. So 6 times 9, on our fingers, 6 finger down, 5 and 4, 54. 5 up in the air and the 1 up in the air, we take the multiplication sign up, it becomes a plus when it's windy and twists, so that gives us 54m to the power of 6. Now so far we've only looked at multiplication. Let's have a look at division. Similar rules here. So if we had P9 divided by P2, where we have a division sign down here on this level, it's going to go up in the air and it's windy, so what's going to happen? It's going to lose its dots. So what was a divide down here will become a subtract up here. So we have P9 divided by P2, well, that's going to give us P7 because, of course, we end up with 9 take away 2 up the top there. Let's just run through another one. C8 divided by C3. Again, same issue. We've got the divide that goes up in the air and loses its dots. We end up with C5. Now, we can also make these ones a bit tougher by introducing the numbers in front of the unknowns. Just like before, it's all about levels. So if we have 24w to the power of 12 divided by 6w to the power of 7, we're going to do the 24 and the 6 first. They're on the level of the division. So 24 divided by 6 is 4. We've then got the w, but we're going to go up in the air. So the divide's going up, losing its dots. So we have 12 take away 7, which gives us 5. Pull it all together, we have 4w to the power of 5. Now we can do it again. Let's see how they could make it tougher. Well, 42r to the power of 7 divided by 7r. Again, we've got our levels, but we've also got r on its own, which we know is r to the power of 1. So 42 divided by 7 is 6. If we've got r7 divided by r, that's r to the power of 6. Pull it together, we get 6r to the power of 6. Now, I mentioned at the beginning that this was only going to work if your unknowns were the same. If we just have a look at something you might see in an exam where they mix them up, so if we've got some y's and some t's, like in this example, we can't actually do the rules that we've just looked at. So if we have 2y to the power of 2 times 4t to the power of 7, the y squared and the t to the power of 7 are going to stay as they are. Now, when we multiply, we can just put them together. You don't have to keep writing out that multiplication sign. However, the 2 and the 4, they can come together. So we'd get 8, but the y squared and the t to the power of 7 would stay as they are. We're not going to make t to the power of 9 or y to the power of 9. They will stay as they are separate. And just to run through another one, you've also got the 4r to the power of 7 times 3s to the power of 4. Hopefully you can see what's going to happen with this one. Again, the 4 and the 3 can come together to give us 12, but the r to the power of 7 and s to the power of 4, they will just come together. So we just end up with 12, r to the power of 7, s to the power of 4. That concludes the indices chapter. Hope you found it helpful, and obviously if you see these in the exam now, you should be able to do these with no problems.